We're moving along with our properties of logarithms. We're now at logarithm of a power property, and I have a theorem for you. This is 12.4b. We've got 9 previous videos that are linked in the description for your pleasure. You just click on them if you need them. We said this in the previous video that logarithmic functions share similar properties with their exponential counterparts. And when needed, the properties of logarithms allow us to manipulate log expressions so we can solve equations or simplify terms. And just as with exponential functions, the base of a log function has to be positive. So here's our theorem for a log of a power. For any positive number x, any number p, and a cannot be smaller than 0, a has to be greater than 0, and it can't be a 1. All right? So for any positive number x and any number p, log base a of x to the p power is going to equal p times log base a of x. All right, so let's see how this works. This theorem says that the logarithm of a power of a number is the exponent times the logarithm of the number. So it's saying that this power of x is going to be multiplied to the log. See? So we're going to do some examples expressed as products. We have log base b of 9 to the negative 5th power. It would equal negative 5 times log base b of 9. And if we see something like this, we've got log base a, and we've got a rational exponent here. Now, if you remember from 7.5a, b, c, and d, we talked about what happens when this index out here is not a 2, which would be a square root. We can rewrite it so that the index is the denominator of the exponent. So this would end up becoming log base a of 5 to the 1/4 power. And we would rewrite it as 1/4 times log base a of 5. All right? So just remember that that root out here is the denominator of the fraction exponent. All right? If we've got log base 7 of 4 to the 5th power, we can do 5 times log base 7 of 4. So now we've got just a square root of 5, don't we? But do you remember that there's an invisible 2 here that we don't usually write for square roots? We just don't write it. We just know that there's a little 2 there for our index in regular square roots, right? So that's going to be our denominator. So we're going to have log base a of 5 to the 1/2 power, which is going to give us 1/2 times log base a of 5. All right? So just remember that little index is the denominator of the rational exponent. All right? If we have log base 10 of 2 to the 20th power, it's going to equal 20 times log base 10 of 2. Now let's see how this works. Let's actually put some numbers in here, okay? We've got it expressed as products. So we're going to say log base 2 of 8 to the 2nd power. It's going to equal 2 times log base 2 of 8. Well, 8 to the 2nd power is 64. So if we had a green 64 here instead of this 8 to the 2nd power, it would mean 2 to the what power equals 64, wouldn't it? Well, 2 to the 6th power equals 64. And over here, 2 to the what power is 8, a 3. We multiply this 2 times that 3, we get a 6. Look at that, it worked out. Isn't that something? Let's try this again. All right, so now what we're going to do is we've got log base 3 of 9 to the 2nd power. We rewrote it so that this 2 exponent is here times log base 3 of 9. See? Took the exponent, put it in the front to multiply it. We took it away from here. So 9 to the 2nd power is 81. So it's almost as if it says log base 3 of 81, right? So 3 to the what power is 81? And 3 to the 4th power. 3 to the what power is 9? 2. So we multiply this 2 times this 2. We get a 4. Yep, it worked. So isn't that cool? For the logarithm of a power? Now, as I promised in the previous video, I'm going to show you this board at the end of every video. And these are the properties of logarithms. We talked about the first one up here. This is equivalence. We did this one in 12.3a. All right, let me get a little closer. This was our last video, the log of a product. This product can be written as sums, okay? This is log of a power. I kind of wrote them in a weird order here. We're going to do quotient next, and then we're going to talk about log of 1 and log of the base, which you may already understand, all right? And I want you to remember that if you see an equal sign with a double-headed arrow, it means equivalent, or it could just be an arrow with two ends to mean equivalent, okay? It just means that becomes that, all right? They're equivalent. All right? So let's move on to log of a quotient in 12.4c, and we'll talk about that property, and I'll have a theorem for you. There's going to be the links to the 9 previous videos for Chapter 12 and those links about rational exponents and about how that index becomes the denominator. There's going to be links in this video's description. I'm going to add this to the Algebra 2 playlist. There'll be a link to that too in this description. And we're going to move on to our next one. I was going to try to get all these properties into one video, but it would have been over a half an hour long, and I didn't want to do that to you. I'd rather break it into little pieces so it's easier to digest. All right? I'll see you next time. Bye.